Kafka is a critically important piece of data infrastructure in real-time systems. Kafka Streams is an important tool in the real-time analytics toolbox. And if you want to ask questions about what's going on in a Kafka Streams application, interactive queries are how you do that. And if you want to ask questions about interactive queries, Bill Bejeck is the guy you ask. I've got him here on the show today. Let's listen in. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined in the studio today by a man who is a committer on Apache Kafka, author of Kafka Streams in Action, staff DevX engineer at Confluent, former coworker of mine and friend, Bill Bejeck. Bill, welcome to the show.
Thank you. Thanks for having me on.
Great to talk to you again. Yeah. Now, I wanted to talk about Kafka Streams interactive queries. And you happen to be one of the, I think it's safe to say, world-leading authorities on the topic. Certainly a small set of the sort of go-to people for that. So this is a part of an ongoing theme we've been exploring on the show about how to query streams. So folks who are listening, that's where this fits in. What are interactive queries?
Interactive queries. If I could give you some context, well, I guess the short answer is interactive queries is the ability to query state of a Kafka Streams application while the application is running. So if you're doing, it could be a key lookup for a simple K table, or it could be an aggregation that's doing some complex work, and you want to see the results as the stream is running, as it's running through the application. So that, in a nutshell, is interactive queries.
There you go. So there's Kafka Streams can create stateful topologies, and interactive queries are a way to look at that state. So, ladies and gentlemen, thank you.
Yeah.
We linked in the show notes are a couple of recent episodes that I did with Anna McDonald, where we talk about Kafka Streams. So if you don't know what Kafka Streams is and you want to dive deep, go listen to those. If you're just joining us on this episode, Bill, brief account. What's Kafka Streams? You wrote the book. What is it?
Well, what's Kafka Streams? It is the native streaming platform for Kafka. Runs as a client application, and it allows you to do stream processing on a topic or topics, do pretty much any kind of transformation you want, and then you output the results back to a Kafka topic.
There you go. So events are arriving at a Kafka topic. Kafka Streams is a way of writing a stream processing application that consumes them, does stuff to them, and then puts the resulting events back into another Kafka topic.
Exactly. Yeah.
Now that stuff gets interesting, and the reason why Kafka Streams exists is because there's a lot of kind of common things that come up. You know, you got to deal with time windows, you got to compute aggregations, you got to do all these things, and you want a library to do that. Before we dig into the specifics of interactive queries, just maybe give us a brief description of, I think you said K-table, maybe I just made that up in my head, but tell us, that unit of state in Kafka Streams, tell us what that is, where it lives, and what's interesting about the way Kafka Streams manages state.
Sure. Well, there's two types of streams in Kafka Streams. You have the event stream, which is the abstraction. The API is called a K stream. And with an event stream, Kafka Streams supports the key value data model. Which makes sense. That's what Kafka does. In an event stream, events that have the same key really aren't related to each other. They just come in. Each one is independent. And then they're
related in that they have the same key, but they don't have any connection in the stream. There's one and there's another, right?
Exactly. It's like, they're coming along like if you were tracking, you're on a website and you're clicking around. Okay, Tim clicked here. okay, he clicked on, books or whatever, but it's just tracking individual events so that they're not really meaningful to each other.
Mhm.
There's no relationship, say,
Right.
explicit. A K table is an update stream. And this is where events with the same key are closely related. And the difference is a later event with the same key will update or will replace a previous event with the same key. So if we went using Tim clicking around a website example, click events, as you clicked on something, let's just say that event's being captured and piped into a Kafka topic.
There's some
And
compute happening on it.
yeah, exactly. We would only your latest click event would be what's captured. It would come in. So let's just say you clicked on books by famous Stoics. That's one click, and then you did a click on classic cigars or something like that. So that's a terrible example. But you clicked on something else that last click event is what would make it into the K table. It's going to update or replace. So that's the main difference. So a K table is an update stream, and it just keeps track of the latest event.
It's fun.
For a given key.
I'm stuck on your example that there's like a book there called like Sticks with Marcus, How I Learned to Love Cigars and Stop Worrying About My Passions or something like that. Yeah.
Yeah.
That's, I'm not a Stoic, not tempted to be a Stoic, but sounds like a good book to me. Yeah. I guess, or you could say maybe there's two topics and one's got clicks. And clicks are just clicks. I think my last click doesn't make this click doesn't mean that click is meaningless.
Yes.
But you could have another topic that maybe is about me or about the books. And it's like a change log of things. And so anytime I update something about my user record, there's a new event there. And so that new event really does replace the old event because now my address has changed.
Yeah, that's a much better example to say that the update stream is user info. It's like, maybe profile information or something like that.
Now, it could also be the result of a computation, right? Like if I group over something, and this is the real-time analytics podcast. So, performing real-time analytics in Kafka streams, if I group over some field and aggregate that, and then I have a table at the end of that, right?
Yeah. Originally, when I was talking about a K table, I was talking about if you were to have a K table,
yes,
on top of a source topic,
right?
Yeah. If in Kafka streams, whenever you do some sort of aggregation, whether it's any kind of aggregation, the result of that operation is a K table. And again, the result. If you just think about a simple aggregation like a count. Uh-huh. Every time you do a count, you're just going to replace, you have a count that's 5, now it's 8. You just want to keep the latest count. So you just keep up, it's an update in that K table, keeping track of the aggregation.
Got it. So let's make up a new event stream. Say we have an app that is for Stoics to share their experiences smoking cigars. And maybe you can add a selfie of you with your buddies, this is very niche. And so anybody who wants to take this and run with it as a startup, I don't think Bill and I are jealous for the idea, but, there's events and each one is a new Stoic somewhere saying, well, I had Romeo y Julieta and it was real good. And we've got their location, say their postal code or something like that. And maybe we could group that stream by postal code and count in the last hour how many Stoics had a cigar inside that postal code. And that is going to be a K table.
Yes, exactly. I always like to, not that the Stoic example is
You're the
great.
one who said it.
I always go with, I know, sorry. Stock trades is my go-to for that.
Maybe,
so if you
okay. The Stoics and cigars was getting a little fanciful. So give us a analytic Kafka streams topology, that's doing some kind of grouping of stock trades. What would we do there? Would we
well, let's say you've got a real-time feed that's bringing in stock trades.
Okay.
And It's partitioned by the ticker symbol. So you're coming
Yes.
in, so you've got this ticker symbol, and you're gonna run an aggregation, and your aggregation is pretty simple. You just want to keep track of the number of shares sold, purchased, and the dollar volume. And your event that comes in is an indicator of whether or not the latest order was a buy or a sell, the price of the price per share, and the number of shares that were involved in the transaction.
I
So
like
you could
that's a
have,
little more believable as a use case. Let's work with that.
yeah, okay. So your aggregation in Kafka Streams, when you do an aggregation, you provide an aggregator that knows how to aggregate the thing you want to do. So your aggregator, you're going to come in, the event comes in, you take your aggregator object, you would simply, you have a field of the number of shares sold, number of shares bought, and then dollar volume bought, dollar volume sold. So the event comes in, you the aggregation is going to be retrieved from a state store, and we'll go into that in a second. But the event comes in, it's going to look up the aggregation by the ticker symbol. It's key value pair lookup from the state store. Look it up, get your aggregation, and then you would do the appropriate, depending on, let's just say it was a sale, you would increment the shares sold by the number of shares in the event, and then you would take the product of the number of shares sold by the share price, and then just add that to the running sum of dollar volume sold. Yeah.
So fundamentally, the reducing function is a sum.
Yes.
You do a multiplication to get it to one, and the other one you just have that in the input event. Got it.
Yeah.
Now that state store, I don't recall offhand. I think we did talk about that with Anna, but briefly, you can think of that as an in-memory hash table backed by a storage on disk, backed by a Kafka topic. Fair enough?
Yes, fair enough.
Okay. Now, I'm glad you came up with this example because I want to know, let's say you work for Confluent. I want to look up CFLT and what the dollar volume was today. I've got this Kafka Streams topology application. I wrote that. I had Kafka Streams in action in front of me, so it was kind of walking me through the process. It was easy. Author's a genius. It's very understandable. So I wrote the topology, and now I've got this K table of these aggregates that I'm computing. And so that is fundamentally an analytical operation happening an event at a time. Don't get more real time than that. But I'd like to query that. What we said at the beginning was stuff goes into Kafka Streams, compute happens, state management happens, it's magical, and then stuff goes out to a Kafka topic, and that's great. But I actually want to ask questions. Like maybe I've got a user interface, and I type in CFLT, and I want to know what the price is right now, and I'm waiting. Like I've just tapped on my phone, and I'm looking for the result. So here's where interactive queries come in. How does that work?
Exactly. So when we were talking about a K table, one of the things I glossed over is K tables are stateful. So it maintains the update stream. When I said like a recent event updates a previous one with the same key, that's stored in a local on disk state store. RocksDB is the default implementation. And it's the same thing for an aggregation. And it's stored by key value. So your ticker symbol would be, your aggregation would be stored in a RocksDB instance by CFLT. That's the key.
That's the key.
Yeah. So interactive queries allows you to view that state in real time, not having to use an external store, because the typical way you'd mentioned earlier is the aggregation computes, it gets output by Kafka Streams to a topic, and typically you'd have to run some sort of connector to export that data into some kind of relational view to see it, relational database to view it.
Other thing that you can serve.
Yeah, exactly. Yeah. So what Kafka Streams has, interactive queries exposes that state store for viewing, so that you provide the key and you can execute a query object that will look that up and return that aggregation to you. You have to provide. So that's fundamentally that's what it is. You provide the key, and it's going to query it, look it up in the store, and then return that result. As of, like you said, it doesn't get any more real time than that. Whatever it was the last time the event came in was stored. That's what you're going to
Last
see.
event consumed. There it is.
Yes.
So what's the API look like? Is this a Java API? Is it a thing over the network? Like, how do I use it if I want to write code against this?
If you want to write code against this, Kafka Streams provides, well, I have to give you a little more context here.
Yeah.
So Kafka Streams is a distributed application, and you have state stores, but the way Kafka Streams is set up, its architecture, it creates, let's say you have an input part, your input topic has 4 partitions. It's going to create 4 tasks for those partitions. Each task is only going to process records on that given partition. So your aggregation is going to be for a single partition, and it's going to have a state store on that state store per partition on local
Each
disk.
task has its own state store, its own
Exactly.
value.
Yeah.
Okay. And I could think about, to a first order approximation, and I know that this isn't formally true of the implementation, but I could think of those tasks as threads if they're all running on the same process, right? It is as if they were threads.
Yeah, and you could have a stream thread per task. That's
Okay.
a great way to think about it. So you have a stream thread per task. So Kafka Streams, you can deploy 4 separate instances, and each instance would be responsible for one partition. And so you have a stream thread, a single task. So you got all the CPU for that machine doing that processing. So the trick is
instances, meaning, let's say we're into running this on bare metal because we like artisanal infrastructure, and you can actually scale that application out into, say, 4 EC2 instances or something like that, and the same process is running, the same code is deployed to all 4 instances, and those tasks get spread out and the partitions get distributed to those 4 parallel running instances.
Yes, exactly. And so as a consequence, you have a state store per partition. You spun up 4 Kafka Streams instances wherever they live, they're running. That means your state is distributed, is now sharded. So you've got 4 separate hosts, each processing, doing an aggregation on a partition's worth of data. And those state stores, all 4 they're distributed across those 4 hosts, those 4 client applications. So what Kafka Streams provides for interactive queries is it has metadata that it knows which host is responsible for which partition of data. So when you query, Kafka Streams provides the internal plumbing. So it provides the metadata for a given key. It knows which host is going to be responsible for that key. And that's as far as it goes. So you have to write your own serving layer. You would have to, I did a talk at Current last year talking about implementing interactive queries, and I used Spring Boot as a serving layer. So you have your REST controller that takes, REST requests from like an HTML page. And you just have a simple GET request where you're passing in a key. So you pass in CFLT. And then your REST controller, the reason to use Spring is it's nice because it wires up all your dependencies. You get your Kafka Streams object, the actual object, and you say, give me the metadata for this key. And it's going to return you a metadata object. And then within that, you can say, okay, what's the active host for this key? And then you would compare the active host. The actual object is, what's it called? Host info, the host info object. You take the host info object and you would say, okay, am I the host?
Me?
Is that me? And then if it is, you execute, you create a query object and Kafka Streams, query, you get back a result, pull out the result from that, and then you would send it back to the client. And that's the happy path. If you don't,
that query object, that's the actual interactive query API there that you're, so the Spring Boot, and you took the words out of my mouth with that, by the way, that's like a sensible way to do it. You're building the serving interface, REST interface yourself. You do that stuff, and then you do the interactive query thing, that query object.
Yeah.
Okay.
You create a query object, and there's a method, or you pass that in, and then it's going to return the result, a query result to you.
And you only do that because you know you've got it here, and what that can do is get the answer from your local state store.
Exactly. That's
the
happy path.
Yeah.
I'm sorry. Go ahead.
Not me.
If it's not you, you still know which host it's going to be. So it's like, okay, it's not, I'm machine A. Okay, I don't have it, but machine C does. So you would do a proxy query to machine C, and it would go through the same code running on all four, and it would do the same comparison, and it'd say, oh, I am the host, and return it, but it would return it to you, the originator, and then you would just take that result and return it to the client. So it's never more than one hop away from where the data actually lives.
Now, is the proxy query Kafka Stream's interactive queries call, or is that proxy query to the host and its REST endpoint?
I've always done it where it just basically, you turn around, you do another REST call to the appropriate instance. You just turn around, you get that host info, and then just from the web controller, you would forward the request to the other instance. And then the host you forward that request to is going to go through the same process. It's going to accept the web request, look up for this key and say, oh, okay, I do have it. And then just return it. But in this case, it's going to return it to the original Kafka Streams instance that issued the query. And then that's going to return it to your client that issued ultimately issued it.
Gotcha. So properly speaking, IQ is an API for querying things out of your local state store. And when state is clustered, it doesn't have the wiring to go find it in the consumer group.
Exactly. You have to implement that yourself.
Gotcha. It sounds like if you were writing that Spring Boot application, you'd probably build a little layer for that. And that's a little piece of framework that could just get that job done in a general way fairly simply.
Yeah. It is work to do, but it's not hard. Like I said, the hard part of knowing which host has which key, that's taken care of for you. And then you have the host name. So it's really just a matter of turning around and doing another query.
Exactly. And at that point, application wise, you've got bigger fish to fry. Like, you've got some service request coming in that you need to load balance and across your cluster and keep track of the names of those things. And this is where we get into API gateways and things like that. And where you and I would go ask Victor how to make Kong do that part for us. That sort of thing.
Exactly. Yeah.
Okay. That really makes sense. And this is sounds like a pretty reasonable way to query a stream when it's a key lookup, and I've already got this Kafka Streams application. I've made the state. I need to expose things by this key. It really gives you everything you need to make that happen.
Yeah. And it's nice from a standpoint of it has the potential to simplify your architecture, because depending on what your needs are for querying, it could make querying like if you had a simple dashboard app, this makes it possible to do that with the existing infrastructure, with a Kafka Streams infrastructure. You could run this dashboard app.
Absolutely. Without having to deploy an extra database or extra infrastructure. It's kind of all right there. And you like that because you had the Kafka Streams app anyway. You needed it anyway. Yeah. Is this an API that's you would say has reached maturity? Is there anything up and coming? Any kips in play to add meaningful things to it?
Well, that happened within the past year or so. The original version of IQ that shipped with Kafka Streams, you would pull back you would use the Kafka Streams object, but you would pull back a read-only version of the state store. It's one thing I'd like to say. Interactive queries is read-only. You can't update the state store. But you would pull back the store itself, a read-only version of the store, and then do the lookups there. And that really wasn't, there was a lot of things that weren't ideal. And so there was my colleague, John Rossler, did an interactive queries version 2 kit. And so now there's an actually querying later. You don't, when you do an interactive query, you actually use a query, like let's say if it's a point lookup, you would use a key query object. And so that's a much better abstraction. So you're not looking at a store or anything like that. You don't have to worry about closing the iterator and leaking memory. You just create a key query, and then you issue that, you hand that over to a method in Kafka Streams, and you get back a query result. So it's a much more natural API versus getting a store and iterating over looking for something.
What's the state store, right? I'm just here trying to make a dashboard. I don't know.
Exactly. And then there's also with that, there's a key query and there's a range query. You can do something beyond key lookups. You can do a range query, which is still done by key, but that allows you to, you could do an open range query, which depending on how much state you have might not be a great thing, but you could pull back the contents, like a large range of records, and then filter on them. So you can almost, using Boolean logic, build up a fairly complex query, if you will, just filtering on, I want a stock price within this range, this many shares, this many shares, and if you kept track of the time, within the past 5 minutes. So you could do the range query and then apply this Boolean logic. So it becomes a little bit more of a robust expression, rich expression.
Do all those results in the case of the range query come back in the same query object, or are they paged, or what do those look like coming back?
You would get it back. So a range query right now would just return you would need to, I'm getting a little bit ahead of myself. You would need to write a custom query to apply the Boolean logic on the Kafka Streams instance, which is what you would ideally want to do, because then you're only going to get back, let's just say you had 1,000 entries in your state store, but your Boolean logic reduces it down to 25 results. That's okay. Using a custom query, that is what you would get returned.
Okay. And I'm guessing that's a Lambda that I pass in and it does the iterator over or something.
Yes, exactly. But that would be ideal, because then you're only returning over the wire. You're only returning back, the actual results versus if you were just you would need the store to return your query would return everything, and then you would filter, and then do the filtering on that. You just really want to get.
Right. Nobody, as they say, nobody has time for that. So. Yeah. If
that makes sense. I've jumped around a little bit there. So.
Oh no, 100%. That I think that closes the loop on the API really well. We'll have a link in the show notes to the book, any other resources on Kafka Streams, and interactive queries that you recommend. I'll make sure those are linked.
I would say the Kafka Streams course we have on Confluent Developer.
Absolutely. That's
is a good.
That was unspoken, but certainly in the plan.
Yeah.
All right. My guest today has been Bill Bejeck. Bill, thanks for being a part of the Real Time Analytics podcast.
Thanks for having me, Tim.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.